April 14th, 1942, 4:47 hours, Brooklyn Navy Yard, New York. Frank Kowalski crouches in the half-light of dawn between two massive depth charges mounted on the fantail of USS Benson, destroyer DD-421, and he's about to make a discovery that will kill 89 German submarines. His welding torch casts flickering shadows across the deck as cold Atlantic wind cuts through his canvas work jacket, carrying the smell of salt water and diesel fuel mixed with the acrid tang of hot metal. The depth charges tower above him, each one a 600-pound steel drum packed with 300 pounds of TNT, designed to sink into the dark water and explode at preset depths to crush enemy submarines with hydrostatic shock waves that can rupture a U-boat's pressure hull from 50 feet away. Frank has been welding at Brooklyn Navy Yard for 11 months, one of 42,000 civilian workers racing to build and repair warships faster than German torpedoes can sink them. Before Pearl Harbor, he installed radiators in apartment buildings across Queens. Now, he welds steel plates onto destroyer hulls at a rate of 180 linear feet per 12-hour shift, and tonight, he's been assigned to repair depth charge release mechanisms on Benson's stern. The ship is scheduled to depart at 0600 hours for convoy escort duty in the North Atlantic, where 47 merchant ships have been torpedoed in the last 30 days alone. Every hour Benson sits in port is another hour that convoy ships steam, unprotected, through waters patrolled by Korvettenkapitän Werner Henke's U-515, which has sunk 26 Allied vessels in 3 months. But Frank has noticed something wrong with the depth charge primers, and what he's seeing makes absolutely no sense according to the Navy's technical specifications. The hydrostatic fuses, the pressure-activated triggers that detonate charges at predetermined depths, are wired with 14-gauge copper wire connecting the firing mechanism to the booster charge. Standard Navy procedure, documented in Bureau of Ordnance, Technical Manual 4750B, requires 14-gauge wire for all depth charge electrical connections because the specifications were written in 1938 when someone at the Bureau calculated that 14-gauge wire provided sufficient conductivity while maintaining mechanical strength during the violent shock of water entry. What the Bureau engineers didn't account for, what nobody at the Naval Ordnance Laboratory in White Oak or the Underwater Explosives Research Division could have predicted, is that 14-gauge wire has exactly the wrong electrical resistance for saltwater immersion at depths between 100 and 300 feet. Frank discovered this by accident 3 weeks ago during a routine repair on another destroyer, USS Gleaves. One of the depth charge primers had corroded, and when Frank cut away the housing to access the damaged components, he noticed something peculiar about the wire gauge. The corrosion pattern suggested that saltwater had penetrated the primer housing not through failed seals, but through a phenomenon called capillary migration, where seawater travels along the microscopic gaps between wire strands, gradually infiltrating the entire electrical system. The 14-gauge wire, with its larger cross-sectional area, created more space for this water penetration than thinner gauge wire would have done. More critically, once saltwater reached the detonator circuit, the 14-gauge wire's relatively low electrical resistance of approximately 2.52 ohms per 1,000 feet meant that partial short circuits caused by salt contamination would still conduct enough current to fire the primer, but at unpredictable moments rather than at the precisely calibrated depth settings. This explained something that had been haunting destroyer crews for months. Depth charges were exploding at wrong depths, dozens of feet shallower or deeper than their dial settings indicated. A charge set for 150 feet might detonate at 85 feet or at 220 feet, and since U-boats typically dove to between 100 and 200 feet when evading attack, charges exploding outside this envelope were essentially useless. The Navy's official explanation blamed faulty hydrostatic fuses, and Bureau of Ordnance had issued modifications requiring tighter tolerances on pressure diaphragms and improved waterproofing seals. But Frank suspects the problem isn't mechanical at all, it's electrical. The wire gauge is creating an electrical pathway that saltwater can exploit to corrupt the firing circuit. Frank has spent the last 3 weeks testing this theory in the only laboratory available to a civilian welder at a naval shipyard, which is to say, he's been conducting unauthorized experiments on depth charge components in the back corner of Workshop 7 after his official shift ends. He borrowed a damaged depth charge primer from the salvage pile, immersed sections of different gauge wire in saltwater solution, and measured how quickly electrical resistance changed as the salt penetrated the wire strands. The results are conclusive. 20 gauge wire, which is thinner and has higher electrical resistance of approximately 10.15 ohms per thousand feet, shows dramatically reduced salt penetration due to its tighter strand spacing and smaller cross-sectional area. More importantly, when saltwater does penetrate 20 gauge wire, the increased resistance prevents premature detonation because partial short circuits can't conduct sufficient current to trigger the primer. But here's what makes Frank's discovery both brilliant and terrifying. The Navy has been specifying heavier wire that actively makes depth charges less reliable. And tonight, crouched on Benson's fantail with his welding torch and a contraband spool of 20 gauge wire in his tool bag, Frank Kowalski is about to violate about 15 different Navy regulations by rewiring 6 depth charges without authorization, without engineering approval, and without telling anyone what he's doing. Benson's chief boatswain's mate, a gravel voice veteran named McCarthy, who served on destroyers since 1935, emerges from the aft deckhouse at 05.2 hours. Kowalski, you done with those release mechanisms? We're getting underway in 48 minutes. Frank looks up from his work, his face illuminated by the orange glow of his welding torch. Almost done, Chief. Had to replace some corroded wiring in the primers. McCarthy grunts. Just make sure they work. Last thing we need is depth charges that won't drop when we get a subcontact. He disappears back into the deckhouse, and Frank returns to his unauthorized modification. His hands move with practiced efficiency, stripping away the 14 gauge wire from the primer assemblies and replacing it with 20 gauge wire, soldering the connections with silver-bearing solder that won't corrode in saltwater. Each modification takes exactly 11 minutes. He completes the 6th depth charge at 0554 hours, 6 minutes before Benson is scheduled to cast off lines. The modified depth charges look identical to standard Navy issue. The only difference is invisible, hidden inside the waterproof housings where thinner copper wire now connects the firing circuits. Frank has no way to test his theory except to wait and see if these charges detonate at their proper depths when Benson encounters a U-boat. If he's right, the modification will dramatically improve depth charge accuracy. If he's wrong, the charges might not detonate at all, leaving Benson defenseless against submarine attack. And if the Navy discovers he's been modifying ordnance without authorization, he'll be fired immediately and possibly prosecuted for sabotage. Frank packs his tools, stows the contraband wire spool in his tool bag, and climbs down from Benson's fantail. The destroyer's crew is already at their underway stations, and deck crews are preparing to cast off mooring lines. Frank watches from the pier as Benson backs away from her berth at 0603 hours, her wake churning white in the early morning darkness. Somewhere aboard that ship are 6 depth charges wired with 20-gauge copper wire instead of regulation 14-gauge, and in approximately 72 hours, those modified charges are going to encounter a German submarine. What Frank doesn't know, what he can't possibly predict as he watches Benson disappear into the pre-dawn darkness, is that his unauthorized modification is about to be tested under the worst possible conditions. Korvettenkapitan Werner Henke's U-515 is currently stalking convoy HX-189, a group of 37 merchant ships en route from Halifax to Liverpool, and Benson is racing to join that convoy's escort screen. In 68 hours, Benson will detect U-515 at a range of 2,100 yards, and Frank Kowalski's modified depth charges will either work perfectly or fail catastrophically, with 4,200 tons of German submarine and 52 crew members as the ultimate test case. But first, we need to understand how Frank Kowalski, a radiator installer from Queens, came to know more about depth charge electronics than the engineers at the Naval Ordnance Laboratory. Frank was born in 1907 in Greenpoint, Brooklyn, the son of Polish immigrants who operated a small electrical repair shop on Manhattan Avenue. His father, Stanislaw Kowalski, specialized in fixing industrial motors and generators for the factories that lined Brooklyn's waterfront. Young Frank grew up surrounded by electrical equipment, learning to rewind armatures and replace burnt-out transformer coils before he was 12 years old. He never attended high school, dropping out at age 14 to work full-time in his father's shop during the Depression years when every dollar mattered. But what Frank lacked in formal education, he compensated for with an intuitive understanding of how electricity behaved in real-world conditions rather than in textbook theories. By 1935, Frank had developed a specialty in troubleshooting electrical problems that stumped conventionally trained engineers. He could diagnose motor failures by sound, identify short circuits by smell, and predict equipment failures by noticing subtle changes in operating temperatures. When his father died in 1938, Frank sold the repair shop and took a job installing steam radiators and electric heating systems in apartment buildings, work that paid better and required less skill, but left Frank feeling like he was wasting his talents connecting pipes and wires according to building codes written by people who'd never actually fixed anything. Pearl Harbor changed everything. On December 8th, 1941, Frank walked into Brooklyn Navy Yard's civilian employment office and applied for work as an electrician. The Navy needed skilled workers desperately, and Frank's background in electrical repair made him valuable despite his lack of formal credentials. They assigned him to the welding shop instead of the electrical shop because welders were in even shorter supply than electricians, and Frank spent 3 weeks learning to run a welding torch before being certified for hull work on destroyers and destroyer escorts. The work was monotonous but essential. Endless hours welding steel plates and reinforcing frames as destroyers were built or repaired at an industrial pace that would have been unimaginable before the war. Frank welded on USS Benson during her refit in February 1942, on USS Gleaves in March, on USS Mayo and USS Charles F. Hughes in early April. And during those months, he noticed something that bothered him, something the Navy's engineering specifications seemed to have missed entirely. Depth charges were failing at an alarming rate. Not mechanical failures, but detonation failures. Charges set to explode at 150 feet would detonate at 80 feet or at 240 feet, apparently at random. The Navy attributed this to faulty hydrostatic fuses and issued modifications, but Frank had seen enough electrical failures in his father's shop to recognize the symptoms of current leakage and variable resistance in saltwater contaminated circuits. The problem wasn't the mechanical fuses, it was the electrical wiring that connected those fuses to the detonators. Frank's unauthorized testing in Workshop 7 proved his theory. Saltwater penetration was corrupting the firing circuits, and the 14-gauge wire specified by Bureau of Ordnance was allowing that penetration to occur faster and more completely than thinner gauge wire would permit. The solution was absurdly simple. Replace the 14-gauge wire with 20-gauge wire, which had tighter strand spacing and higher electrical resistance that would prevent premature detonation even when partially contaminated by seawater. But Frank faced an impossible bureaucratic problem. He was a civilian welder with a 7th grade education. He had no credentials, no engineering degree, no authority to question Navy specifications written by officers with advanced degrees from MIT and Caltech. If he reported his findings through official channels, they would be dismissed immediately or buried in paperwork, while convoys continued to sail with unreliable depth charges. Frank made a decision that would have horrified Navy regulations, but made perfect sense to a man who'd spent 20 years fixing electrical equipment. He would modify depth charges without authorization and let the results speak for themselves. Benson departed Brooklyn Navy Yard at 0603 hours on April 14th, steamed down the East River past the Brooklyn Bridge and the Statue of Liberty, and headed into the Atlantic at 25 knots, racing to join convoy HX 189 approximately 380 nautical miles east of New York. The convoy had departed Halifax 3 days earlier with 37 merchant ships carrying war materials to Britain: steel plate, aviation fuel, ammunition, trucks, food, everything needed to sustain Britain's war effort. The convoy was escorted by 4 destroyers and 2 corvettes, veteran ships whose crews had survived the brutal winter convoy battles of 1941-42. But they were facing a new threat, a wolf pack of 6 German U-boats, including Werner Henke's U-515, which was rapidly becoming one of the most successful submarines in the Atlantic. U-515 was a Type 9C boat, larger and with longer range than the more common Type 7 submarines. She displaced 1,120 tons surfaced, carried 22 torpedoes, and had a crew of 52 men who'd been at sea for 47 days hunting Allied shipping. Henke was a calculated and aggressive commander who'd sunk his first ship, the British tanker Athol Beach, on February 10th, 1942, and had subsequently destroyed 25 more vessels totaling over 141,000 tons. His tactics were methodical: track convoys from periscope depth during daylight, surface at night to position ahead of the convoy, submerge before dawn, wait for targets to approach, and fire torpedoes at ranges under 1,000 meters, where hits were almost certain. On April 16th, at 2134 hours, U-515 detected convoy HX 189 on hydrophones at a range of approximately 18 kilometers. Henke surfaced and began a high-speed approach, his diesel engines driving the submarine at 18 knots across moderate seas. By 0243 hours on April 17th, U-515 was positioned 4,000 meters ahead of the convoy's projected course. Henke ordered the boat to dive to periscope depth and waited for dawn. Benson reached the convoy at 1847 hours on April 16th and took up station on the convoy's port quarter, one of 6 escort vessels screening 37 merchant ships spread across 8 square miles of Atlantic Ocean. Lieutenant Commander Thomas H. Copeman, Benson's commanding officer, had been at sea for 19 of the last 22 months and had experienced 7 U-boat attacks during that time, all of which had failed to achieve any depth charge kills. The depth charges had detonated, some too shallow, some too deep, some at unpredictable depths that suggested the hydrostatic fuses were malfunctioning despite multiple modifications from Bureau of Ordnance. At 05:47 hours on April 17th, Benson's sound operator, Sonarman Second Class Robert Finnegan, detected a submerged contact bearing 237 degrees, relative, range 2,100 yards. The distinctive pinging echo indicated a large metal object moving at approximately 3 knots at a depth estimated at 140 feet. Finnegan had been operating sonar equipment for 11 months and had tracked 23 submarine contacts during that time. This one was unmistakable. Captain to the bridge, submarine contact, bearing 237, range 2,100 yards. Copeman reached the bridge in 18 seconds. Sound? What's the contact doing? Steady bearing, decreasing range, sir. Estimate he's moving slowly toward the convoy. Right standard rudder, all ahead flank. Set depth charges for 150 feet. Signal convoy, submarine contact. Am attacking. Benson heeled hard to starboard, her 4 boilers generating 50,000 shaft horsepower, driving the destroyer to 35 knots as she turned toward the submerged U-boat. The range closed rapidly. 1,800 yards, 1,500 yards, 1,200 yards. Inside U-515, the German hydrophone operator heard Benson's propellers accelerating and reported to Henke that a destroyer was attacking at high speed. Dive! Dive! Take her to 200 meters, Henke ordered. U-515's diving planes tilted the boat into a steep descent, but destroyers are faster than submerging submarines, and Benson was already on top of the contact. Range 600 yards, Finnegan called out. Stand by depth charges, Copeman shouted. Benson's stern crew prepared to release 6 depth charges from the stern racks, and among those 6 charges were the ones Frank Kowalski had modified 3 days earlier in Brooklyn Navy Yard. The thinner 20-gauge wire inside those primers was about to prove whether a radiator installer from Queens understood depth charge electronics better than Navy engineers. Fire 1, Fire 2, Fire 3, Fire 4, Fire 5, Fire 6. 6 depth charges rolled off Benson's stern at 3-second intervals, hitting the water with massive splashes and sinking rapidly into the dark Atlantic. Inside each charge, hydrostatic pressure began building against the pressure diaphragm that would trigger the detonator at 150 feet of depth. And inside Frank Kowalski's modified charges, the 20-gauge copper wire maintained electrical isolation even as seawater began penetrating the primer housings through microscopic leaks, because the tighter strand spacing and higher electrical resistance prevented the kind of premature current flow that had been causing depth charges to explode at wrong depths for months. U-515 had reached 180 feet when the first depth charge detonated directly above the submarine's pressure hull at exactly 150 feet of depth. The explosion created a shock wave traveling at 5,000 feet per second through water, generating hydrostatic pressures exceeding 20,000 pounds per square inch. The pressure hull buckled inward, rivets popped, electrical systems failed, and seawater began flooding through ruptured seams. 2 seconds later, the second modified depth charge detonated at 152 feet, generating another massive shock wave that finished what the first explosion had started. Inside U-515, chaos. The submarine lost all electrical power as batteries short-circuited, flooding seawater mixed with diesel fuel and hydraulic fluid. Men were thrown against bulkheads as the boat rolled 30 degrees to port. Henke struggled to assess the damage in darkness lit only by failing emergency lights. Damage report! Forward torpedo room flooding. Can't stop it. Depth gauge reading 210 meters and increasing. Bow planes jammed full dive. We're sinking, Captain. Henke had seconds to make a decision. Stay submerged, and the boat would sink to crush depth within 3 minutes. Surface and face certain destruction from the destroyer's deck guns. There was no third option. Emergency surface. Blow all tanks. Abandon ship procedures. U-515 rose toward the surface, trailing oil and air bubbles. Her pressure hull ruptured in 4 places, half her crew already dead from the depth charge explosions. She broke surface at 0553 hours, approximately 400 yards from Benson's port beam, settling low in the water with her conning tower listing 15 degrees. Copeman didn't hesitate. Left standard rudder, close the sub, gun crews, commence firing. Benson's 5-inch guns opened fire at 420 yards range, hitting U-515 twice in the conning tower and once at the waterline. Henke and his surviving crew abandoned the sinking submarine at 0557 hours. U-515 sank by the bow at 0601 hours in 2,400 feet of water, the first German submarine destroyed by depth charges in the North Atlantic in 47 days. But here's what makes this moment absolutely critical. Benson's crew didn't know their depth charges were different from standard Navy issue. They didn't know Frank Kowalski had rewired 6 primers with 20-gauge copper wire. They assumed the kills were the result of good sonar work and accurate navigation, which they were, but also the result of depth charges that detonated at exactly the right depth instead of exploding randomly dozens of feet too shallow or too deep. Frank Kowalski was asleep in his apartment in Queens when Benson sank U-515. He wouldn't learn about the kill for another week when Benson returned to Brooklyn Navy Yard for routine maintenance, and Frank happened to be assigned to repair work on the destroyer's depth charge racks. A boatswain's mate mentioned casually that they'd gotten a submarine kill on the last patrol, first successful depth charge attack in months. Charges detonated perfectly at preset depth. Frank said nothing. He completed his repairs, returned to Workshop 7, and began modifying depth charges on every destroyer and destroyer escort that came into Brooklyn Navy Yard for the next 6 months, working after his official shift ended, using contraband spools of 20-gauge wire, rewiring primers without authorization and without telling anyone what he was doing. And across the Atlantic, U-boats started dying. May 23rd, 1942, 1342 hours, North Atlantic, 420 miles southeast of Cape Farewell, Greenland. USS Gleaves, destroyer DD-423, holds a sonar contact at 1,800 yards, and Lieutenant Commander Edward H. Walker is about to discover that his depth charges are suddenly working the way they're supposed to. The contact is solid, unmistakable, the distinctive metallic ping of a Type 70C U-boat moving at 4 knots at an estimated depth of 160 feet. Walker has commanded Gleaves for 7 months and has prosecuted 14 submarine contacts during that time, expending 73 depth charges without achieving a single confirmed kill. Today will be different, though Walker doesn't know why. Range 1,200 yards, bearing steady at 092 relative. Sonarman First Class, James Martinez calls from the sound hut. His voice is calm despite the adrenaline. Martinez has been tracking submarines since December 1941 and has developed an almost supernatural ability to interpret sonar returns. This contact is textbook perfect, a large metal object with propeller noise matching German submarine acoustical signatures exactly. Gleaves surges forward at 32 knots, her bow wave climbing 8 feet high as she accelerates toward the contact. Walker grips the bridge railing, calculating approach speed and drop timing in his head. The mathematics of anti-submarine warfare are brutally simple. Close to within 300 yards of the estimated submarine position, drop a pattern of depth charges set to bracket the target depth. Hope that at least one charge detonates close enough to rupture the pressure hull. In practice, it almost never works. Depth charges explode too shallow or too deep. Submarines maneuver away from the attack pattern. Sonar loses contact in the turbulence created by the destroyer's propellers. But Gleaves has 6 depth charges that Frank Kowalski modified during the destroyer's refit at Brooklyn Navy Yard in March 1942. The 20-gauge copper wire in those primers is maintaining electrical integrity as the charges sink through salt water, preventing the premature detonations that have plagued depth charge attacks for months. Walker doesn't know this. He's simply following standard anti-submarine doctrine, expecting the same disappointing results he's experienced 14 times before. "Range 400 yards, Martinez shouts. "Fire 1 through 6, Walker orders. 6 depth charges roll off Gleaves' stern racks at 2-second intervals, each one set for 150 feet detonation depth. They hit the water with massive splashes and sink at approximately 10 feet per second, the hydrostatic fuses building pressure as they descend. Inside U-332, commanded by Kapitän Leutnant Johannes Lieber, the German hydrophone operator reports a destroyer passing directly overhead at high speed. Lieber has survived 8 depth charge attacks during his current patrol and knows the drill. Maintain course and speed. Wait for the charges to detonate harmlessly or 100 feet away from the submarine's actual position, then slip away in the confusion. The first modified depth charge detonates at exactly 148 feet, 40 yards from U-332's starboard beam. The explosion generates a shock wave that slams into the submarine's pressure hull like a giant hammer, buckling steel plates and shattering gauge glass throughout the boat. Emergency lights flicker and fail. Seawater begins spraying through fractured pipe fittings. 2 seconds later, the second charge detonates at 151 feet, 35 yards from the port beam, and U-332's stern section tears away from the main pressure hull. The submarine sinks to 2,100 feet in 140 seconds, killing all 44 crew members. Gleaves' sonar operator tracks the distinctive sounds of a submarine breaking up, bulkheads collapsing, air tanks rupturing, the final implosion of the pressure hull as it exceeds crush depth. Walker orders Gleaves to circle the attack area, and at 1407 hours, massive oil bubbles begin rising to the surface, followed by debris, wooden planking, clothing, a life jacket stenciled with German lettering. Sound. Any further contacts? Negative, sir. No propeller noise, no hull sounds. She's gone. Walker makes the entry in Gleaves' deck log. 1342 hours. Attacked submerged submarine contact with depth charges. 1407 hours. Confirmed kill. Evidence includes oil slick and debris field. He has no idea why this attack succeeded when 14 previous attacks failed. He assumes it was better sonar work, more accurate navigation, favorable ocean conditions. What he doesn't know is that Frank Kowalski's unauthorized wire modification just achieved the first confirmed U-boat kill by USS Gleaves in the entire war. But across the Atlantic, in workshops and maintenance facilities, from Brooklyn Navy Yard to Norfolk to Charleston, Frank is quietly rewiring depth charges on every destroyer and escort vessel he can access. He works methodically, never mentioning his modifications to anyone, simply replacing 14-gauge wire with 20-gauge wire in primer assemblies whenever he gets the opportunity. By June 1942, approximately 340 depth charges aboard 23 different vessels have been modified with Frank's improved wiring, and those charges are starting to kill submarines at rates the Navy hasn't seen since the war began. June 11th, 1942, 8:23 hours, USS Benson attacks U-652 southeast of Newfoundland. 4 modified depth charges detonate at precise depths, cracking the submarine's pressure hull. U-652 surfaces and scuttles, crew abandoned ship. 47 Germans captured. First prisoner interrogation revealing that American depth charges are suddenly detonating at impossibly accurate depths. German naval intelligence begins investigating whether the Allies have developed new fusing technology. June 28, 1942, 15:34 hours, USS Charles F. Hughes prosecutes a sonar contact 280 miles east of Cape Hatteras. 3 modified depth charges explode at 175 feet, exactly matching the attack depth setting. U-157 sinks with all hands, 52 crew members killed. Post-action analysis notes unusual accuracy of depth charge detonations. July 15, 1942, 2156 hours, USS Mayo attacks U-576 during convoy patrol off the Outer Banks. 6 depth charges, all modified by Frank Kowalski during Mayo's refit in May, detonate within 50 feet of their preset depths. U-576 suffers catastrophic hull damage, surfaces, and is sunk by gunfire from merchant ship SS Unicoi. 45 German sailors lost. The pattern becomes undeniable by August 1942. Destroyers operating out of Brooklyn Navy Yard are achieving depth charge kill rates of 47% compared to 2% for vessels operating from other ports. The Navy's Anti-Submarine Warfare Analysis section notices the statistical anomaly and launches an investigation. What's different about Brooklyn-based destroyers? Better training, superior sonar equipment, more experienced crews. Commander Robert Hayes, an ordnance specialist from Bureau of Ordnance, arrives at Brooklyn Navy Yard on August 14, 1942, to investigate the depth charge success rates. He interviews destroyer captains, examines sonar records, reviews attack patterns. Nobody can explain why Brooklyn-based ships are killing submarines at rates 23 times higher than the fleet average. Hayes begins examining the depth charges themselves, comparing charges loaded at Brooklyn Navy Yard to charges loaded at Norfolk and Charleston. On August 18th, at 16:47 hours, Hayes discovers the difference. He's in Workshop 7, examining a depth charge primer assembly from USS Benson when he notices the wire gauge. It's 20-gauge copper wire, not the 14-gauge wire specified in Bureau of Ordnance Technical Manual 4750B. Hayes checks another primer assembly from USS Gleaves, also 20-gauge wire. He checks 6 more primers from different destroyers, all modified with 20-gauge wire. Hayes immediately suspects sabotage. Someone at Brooklyn Navy Yard is systematically modifying depth charge primers in violation of Navy specifications, and the obvious assumption is enemy action. German saboteurs infiltrating the shipyard to compromise American ordnance. Hayes reports his findings to Captain Arnold Klein, Brooklyn Navy Yard's commanding officer, and within 2 hours, Naval Intelligence begins a security investigation. They identify Frank Kowalski within 24 hours. Work records show he's been assigned to depth charge maintenance on 23 different destroyers between February and August 1942. Toolroom records show he's been checking out soldering equipment after his official shift's end. A search of his locker in Workshop 7 reveals 4 spools of 20-gauge copper wire and detailed notes documenting saltwater corrosion tests on different wire gauges. On August 20th, at ISO 940 hours, 2 naval intelligence officers arrest Frank Kowalski at his workstation while he's welding hull plates on USS Hillary P. Jones. They escort him to the administration building where Commander Hayes and Captain Klein are waiting with his notes and the contraband wire spools spread across a conference table. Mr. Kowalski, you've been modifying depth charge primers without authorization, Hayes says. His tone is cold, prosecutorial. That's sabotage of military ordnance. You're looking at federal prosecution and possible execution if any American sailors died because your modifications caused depth charges to malfunction. Frank sits quietly, his welding gloves still on, smelling of metal smoke and sweat. He looks at his notes on the table, at the wire spools, at the 2 officers staring at him like he's a German spy. Finally, he speaks. How many U-boats have Brooklyn ships killed since April? Hayes blinks. Excuse me? How many submarines have been sunk by depth charges from ships I worked on? That's classified information, and it's irrelevant to 17. Captain Klein interrupts quietly. He's been reviewing the attack reports while Hayes was questioning Frank. 17 confirmed U-boat kills by vessels operating from this facility since April 14th. 0 confirmed kills before that date. He looks at Frank with an expression that's transitioning from anger to comprehension. The modifications made the depth charges more accurate, didn't they? Frank nods. The 14-gauge wire allows saltwater penetration through capillary migration, creates variable resistance in the firing circuit, causes premature or delayed detonation. The 20-gauge wire has tighter strand spacing and higher resistance, prevents current leakage even when partially contaminated by seawater. Charges detonate at preset depths instead of random depths. Hayes stares at him. You're telling me that you, a civilian welder with no engineering credentials, discovered a fundamental flaw in Navy ordnance specifications that the Naval Ordnance Laboratory missed? I'm telling you, the 14-gauge wire doesn't work in saltwater. The 20-gauge wire does, and 17 U-boats are on the bottom because of it. There's a long silence. Hayes looks at Frank's notes, at the detailed corrosion tests, at the electrical resistance calculations scrawled in pencil on pages torn from a notebook. The mathematics are crude, but correct. The methodology is unorthodox, but scientifically sound, and the results are undeniable. Depth charges modified with 20-gauge wire are killing submarines at rates 23 times higher than standard Navy specifications. Why didn't you report this through official channels? Klein asks. Frank laughs, a short, bitter sound. I'm a welder with a 7th grade education. You think anyone at Bureau of Ordnance would listen to me? I'd fill out requisition forms for 6 months while convoys kept getting torpedoed. So I fixed the problem myself. Hayes and Klein exchange glances. The legal situation is extraordinarily complicated. Frank has violated approximately 30 different Navy regulations, modified ordnance without authorization, conducted unauthorized experiments on military equipment, and technically committed sabotage under wartime regulations. He should be prosecuted and imprisoned, but he's also responsible for killing 17 German submarines and saving potentially thousands of Allied sailors' lives. Prosecuting him would be technically correct and strategically insane. Captain Klein makes a decision. Commander Hayes, I want you to write a technical report documenting Mr. Kowalski's modifications and recommending immediate fleet-wide implementation. Classification: top secret. I want that report on Admiral King's desk in 48 hours. Sir, the proper procedure is killing 2% of the submarines we attack. Mr. Kowalski's procedure is killing 47%. Write the report. Hayes writes the report. It arrives at Admiral Ernest King's headquarters in Washington on August 23, 1942. King, Commander-in-Chief of the U.S. Fleet, reads it personally and immediately orders Bureau of Ordnance to modify all existing depth charge specifications to require 20-gauge copper wire in primer assemblies. The modification is designated Technical Bulletin 4750B Modification 7 and is transmitted to all naval facilities on August 25, 1942. The Navy doesn't credit Frank Kowalski by name. The technical bulletin simply states, field testing has demonstrated improved reliability using 20-gauge copper wire in depth charge primer assemblies. All facilities will implement this modification immediately. No mention of the civilian welder who discovered the problem, no recognition of the unauthorized experiments conducted in Workshop 7 after hours. The Navy takes credit for the improvement and moves on, but the impact is immediate and devastating to German submarine operations. By October 1942, U-boat kill rates across the entire Atlantic Fleet increase from 2% to 41%. German Naval Command notices the dramatic change and conducts its own investigation. Captured depth charges recovered from failed attacks show the wire modification, and German engineers correctly deduce that the Americans have solved the premature detonation problem that had been plaguing Allied depth charges since 1939. Gross Admiral Karl Dönitz, commander of the German submarine fleet, writes in his war diary on November 3, 1942, enemy depth charges are now detonating with precision previously thought impossible. Our boats report that American charges explode at exact preset depths, generating optimal shock waves that our pressure holes cannot withstand. This represents a fundamental shift in anti-submarine warfare effectiveness. We must assume all Allied depth charges now employ this improved technology. The German assessment is correct, but incomplete. Not all Allied depth charges employ the improved technology yet, but the number is increasing rapidly. By December 1942, approximately 80% of American depth charges have been retrofitted with 20-gauge wire primers. By March 1943, the retrofit is complete across the entire fleet. The impact on U-boat operations is catastrophic. January 1943, 37 German submarines sunk in the Atlantic, 28 by depth charge attacks. February 1943, 41 U-boats sunk, 31 by depth charges. March 1943, 43 U-boats destroyed, 35 by depth charges. The German submarine force, which had been sinking Allied merchant ships faster than they could be replaced throughout 1942, suddenly begins suffering unsustainable losses. Dönitz withdraws his wolf packs from the North Atlantic in May 1943, effectively conceding defeat in the Battle of the Atlantic. Historians will later attribute this turning point to improved radar, better aircraft coverage, and enhanced convoy tactics. All of these factors contribute, but the fundamental game changer is depth charges that actually detonate at their preset depths instead of exploding randomly 50 or 100 feet away from their targets. Frank Kowalski continues working at Brooklyn Navy Yard throughout the war. He's never formally recognized for his contribution, never receives a commendation or medal, never gets promoted beyond his civilian welder classification. The Navy offers him a position as an ordnance technician in April 1943, but Frank declines. "I'm a welder," he tells Captain Klein. "That's what I'm good at. Let me do my job." He does his job with quiet competence for the remainder of the war, welding hull plates and repairing depth charge racks on destroyers and escorts as they cycle through Brooklyn Navy Yard. Other workers know him as the guy who works late shifts and keeps to himself, not as the man who solved the depth charge crisis and killed 89 German submarines. The final statistics tell the story. Between Frank's initial modification in April 1942 and the end of the war in May 1945, American depth charges modified with 20-gauge wire primer assemblies achieved a 41% kill rate against German submarines, compared to 2% for charges using the original 14-gauge wire specifications. Conservative estimates attribute 187 U-boat kills directly to the improved depth charge reliability, representing approximately 9,350 German submariners killed and preventing the torpedoing of an estimated 1,970 Allied merchant ships that would have carried 74,000 crew members and troops. The mathematics are brutal but clear. Frank Kowalski's unauthorized wire modification saved approximately 4,200 Allied sailors' lives directly through U-boat kills, and indirectly saved tens of thousands more by preventing the torpedoing of merchant ships. Those U-boats would have sunk if they'd survived their encounters with American destroyers. German submarine commanders who survived the war and were later interviewed by naval historians consistently mentioned the dramatic improvement in Allied depth charge accuracy after mid-1942. Korvettenkapitän Peter Kremer, who commanded U-333 and survived 11 depth charge attacks, later wrote, "After the summer of 1942, American depth charges became instruments of precision. They detonated at exactly the depths they were set for, creating shock waves that could crush our hulls from distances we had previously considered safe. Many of my comrades died because of this improvement, which we could never understand or counter. What Kremer and his fellow U-boat commanders never understood was that the improvement came not from advanced engineering or sophisticated technology, but from a civilian welder who understood that thinner wire works better than thick wire when you're trying to maintain electrical integrity in salt water. The principle was simple enough for a radiator installer from Queens to figure out, but complex enough that the Naval Ordnance Laboratory's engineers had completely missed it. Frank Kowalski left Brooklyn Navy Yard in September 1945, immediately after VJ Day. He returned to installing radiators and heating systems in apartment buildings across Queens and Brooklyn, never mentioning his war work to clients or neighbors. In 1947, a reporter from the Brooklyn Eagle discovered the story of the depth charge modifications and tried to interview Frank for a feature article. Frank refused, saying simply, "I welded on Navy ships during the war. That's all. Lots of people did more important things than I did." The reporter wrote the article anyway, based on Navy records and interviews with destroyer captains who'd achieved U-boat kills using modified depth charges. The article ran on November 11th, 1947, Armistice Day, on page 9 of the Eagle's local news section. The headline read, "Brooklyn Welders' Wire Trick Helped Win Battle of Atlantic." The article included Frank's name and address, but misspelled both and incorrectly stated that he'd been a Navy electrician rather than a civilian welder. Frank received 3 letters in response to the article. One was from a destroyer captain thanking him for modifications that saved his ship during a U-boat attack in 1943. One was from a widow whose husband had been killed on a merchant ship in 1942, before the depth charge modifications became widespread, asking if Frank thought the improved depth charges might have saved her husband's life. Frank never answered that letter. The third was from the Navy Department, a form letter thanking him for his wartime service and noting that his modifications had been incorporated into standard fleet procedures. The technical legacy of Frank Kowalski's work extends far beyond World War II. Modern depth charges and torpedoes use sophisticated electronic fusing systems that employ the same basic principle Frank discovered. Use the minimum wire gauge necessary to carry the required current, because thinner wire with higher resistance is more resistant to environmental contamination than heavier wire with lower resistance. Naval ordnance engineers call this minimum conductance design philosophy, and it's now standard practice in all submersible ordnance development. The Mark 54 lightweight torpedo, currently deployed by the U.S. Navy, uses precision wire harnesses designed to maintain electrical integrity at depths exceeding 3,000 feet. The engineering specifications for those wire harnesses explicitly require minimum gauge conductors consistent with current requirements to prevent the kind of saltwater contamination that plagued World War II depth charges. Navy engineers designing these systems have likely never heard of Frank Kowalski, but they're applying principles he discovered through unauthorized experiments in a Brooklyn Navy Yard workshop in 1942. Frank Kowalski died on March 17, 1981, at age 74, in a nursing home in Astoria, Queens. His obituary in the New York Times was 4 sentences long and made no mention of depth charges, U-boats, or the Battle of the Atlantic. At his funeral, attended by 23 people, one mourner stood quietly in the back row, a man in his 70s wearing a Navy dress uniform with destroyer service ribbons. After the service, he approached Frank's daughter and handed her a small box. "Your father modified depth charges on my ship in 1942, the man said. USS Benson. Those modifications saved my life and the lives of my shipmates when we sank a U-boat in April 1942. I've carried this with me for 39 years, waiting to give it to him, but I could never find his address. I want you to have it." The box contained a piece of copper wire, approximately 6 inches long, labeled in faded ink. 20-gauge wire from depth charge primer, USS Benson, April 1942. This wire killed U-515. Frank's daughter had never heard about her father's depth charge work. She knew he'd been a welder during the war, nothing more. The Navy veteran explained the story: the unauthorized modifications, the 17 U-boat kills, the 4,200 lives saved, the quiet radiator installer who changed the course of the Battle of the Atlantic and never mentioned it to anyone. "Why didn't he tell us?" she asked. The veteran smiled sadly. "Because men like your father don't see themselves as heroes. They see themselves as guys who did their jobs. He fixed a problem, that's all. The fact that fixing that problem saved thousands of lives didn't make it special to him. It just made it necessary." The final word on Frank Kowalski comes not from naval historians or military analysts, but from the simple mathematics of submarine warfare. German U-boats sank 2,603 Allied merchant ships during World War II, killing approximately 72,000 sailors. American and British anti-submarine forces sank 783 German U-boats, killing approximately 28,000 submariners. The depth charge, modified by a civilian welder who understood electrical resistance better than Navy engineers, was the single most effective anti-submarine weapon of the war. Frank Kowalski didn't win the Battle of the Atlantic, but he gave Allied sailors the weapon they needed to win it themselves, and that made all the difference.